students. Today we have Proposition 11 of Book 3. If two circles touch one another internally, okay, like this here, see two circles touching one another internally, and if the centers be taken, and if a straight line joins those centers, and if that straight line be extended up into the outer points of the biggest circle, one of the points of terminus will touch exactly the point of contact between the two circles where they touch each other. Okay? So it will be something like this. You erase that a bit. Two circles touching each other at one point, obviously only one point, internally. And the centers of each circle be taken. This is the center of this circle, this is the center of the circle. Join their lines, join their centers, and then extend that line, one of the points of terminus, I don't know if that's the right way to say it, is going to touch, is going to come into contact with the point of contact of the two circles. For if not, guess what we're going to do? A reductio. For if not, let the two centers be taken. We have a black circle and a blue circle here. There's the center of the blue circle, right here. I'll put center, center, and there's the center of the red circle. I know it doesn't look like the center of the red circle, but as in many reductios, the image doesn't really fit with the imagination because it's the only way you can do it. Okay, so let that be the center such that when you join the two lines, let's join them with this green thing, green, connect the two centers with that straight line, and then extend that straight line to there. I hope you can see that. You see, in this case, what Mr. Smartypants says, that it'll fall not at the point of contact, but away from the point of contact. Okay, that's no problem. We'll take his position and we'll run with it. Let's see if this marker works. Yep. Okay, so let's get at this point of contact, let's drop a line to the center of the red circle, and let's drop a line to the center of the black circle. Now we have a triangle. Great. And we know in any triangle, two sides taken together are greater than the third side. So this side and this side are greater than this side. This blue line and the green line are greater than the blue dashed line. Great. But look, let's see, we got a center here. But look, this is the center of the red circle. Let me make sure I get this right again. This and this are greater than this. But, okay, this is equal to this because this is the black circle, here's the center, and these are two radii of the center, okay? So this is the center radii. All radii of circles are equal. So this is equal to this. But this and this are greater than this, and this is equal to this. This and this, then, are also greater than this. Two things equal to the same thing are equal to each other. Two things equal to the same thing are also greater than the same thing. If one is greater, the other is greater. They're equal. So this and this are equal, but this and this are greater than this. Therefore, this and this are greater than this because this is equal to this. Great. So I got this and this being greater than this. Now look at that. This and this are greater than this. Okay? Let's take out that thing that they have in common, and we know that the remainders will still have the same relationship. That is, this will still be greater than this. Great. No problem, right? Now we have this being greater than this. Now, let's look at the red circle. Here we have the center, and these are radii of that center. Therefore, this is equal to this. Well, if this is equal to this, and this is greater than this is also greater than this. The part being greater than the whole, which is absurd because the part is not greater than the whole. So we have it being not greater than the whole and greater than the whole at the same time in the same respect. Is and is not absurdity. Therefore, that thing that we granted must be false because everything else in the argument was true and logical and valid and everything's fine. There's got to be something wrong. If our conclusion is absurd, there's got to be something wrong with what we did. And the only thing that could be wrong is that it's false, that this falls away from the point of contact. So if you join the centers, it must be this kind of situation. Joining the centers, extend the line, one of the points of terminus will come into contact with the point of contact where the two circles touch internally. Therefore, if two circles touch one another internally, and the centers be taken, and those centers be joined by a straight line, and that straight line be extended, one of the points of terminus of that straight line will fall right on the point of contact where the circles touch internally. Quod erat demonstrandum. Thank you. Bye.